spitting, no bad words.
No extra.
Eric?
Alright,
It's actually hard.
so once again, like we said, when things are explicit, they are clear and fully expressed. An example of that would be like me saying that it was a dark and stormy night. There's no doubt as to what kind of a night it was. It was dark and it was
Stormy.
If I say something implicitly, then that means I am what? I'm not clear, right? Implicit sounds like what word?
Implied.
Implied, right?
Oh, I forgot. Go back.
So this is something that is implied, though not fully
Understood.
or directly
Compressed.
expressed, right?
Okay.
So what would be another way of saying that it's a dark and stormy night
It might have been.
without really saying it's dark and stormy?
It was
Might have been dark and stormy night.
It was green.
Could I say
It was not a bright
the trees
We're swaying. with the
Trees
wind.
were wet.
How will it go back?
were swaying
I wouldn't know.
wildly
Across the horizon.
and the gutters
This is kind of descriptive and express.
were
Wait a minute.
overflowing.
Not to be explicit because the trees were swaying.
Like this? Or
The trees were swaying wildly and the gutters were overflowing. Is that being explicit as to what's happening?
No, but it's like it's raining.
Not necessarily, right? But it's implying that it could be raining, right?
Yeah.
Could it be that the gutters were overflowing just, because
Yes.
somebody flushed the toilet too much? They left the water on outside on their lawn and
Wow. Wasting water.
wasting water?
That's your.
Okay. So do you understand the difference?
Yeah.
Implicit, explicit. Let's go back to the mathematical example, okay? So like I said earlier, if I were to tell you that y was equal to 1 over x, that's pretty explicit. It's pretty clear and defined as to what y is. Y is written as a function of x. It's pretty straightforward. If I were to write that same equation a different way, it would be understood as implied or implicit. So I would write xy is equal to 1. What is this implying?
It's implying that 1 multiplied x and y equals to 1.
Nice.
It's implying that
Y equals 1 over
y equals 1 over x, but is it telling me that y equals 1 over x straight
No.
directly? No. So this implies y is equal to 1 over x, but it's not saying it directly. You understand the difference? Yes? So we're going to be working with problems today and in the future where we have equations that are not explicitly defined. Okay, there's equations where they may not be y equals. And if they are y equals, they might be y equals and the stuff on the other side is not in terms of just one variable, Adriana, but in terms of more than one variable. Okay, so it might be y equals, but there might be just one y here, but there might be some y's on the other side of the equals also, and some other x's over there. Okay, so it's not really explicitly defined in terms of just one variable, that would be defined in terms of multiple variables. Okay, and those equations are a little bit more difficult to work with, right? And they're kind of easy to identify. You can pretty much just like look at this guy right here, and you see that it has x's and y's all jumbled up together.
Yeah.
Yes? Do you think that would be easy to make y equals? Could we make a y equals if we wanted to? Yes, but would it be easy? No, okay? So that's an example of a problem that you know that if they ask me to get its derivative, I'm going to have to get it in a method called implicit. Yes? If that makes any sense. So you're going to use implicit differentiation, okay, when the equation cannot be solved for y, or it would be difficult to solve for y. Not necessarily that we can't solve for y in that problem, but it would just be difficult. And the answer we would end up with would not be something 3. That makes any sense?
Yeah.
For example, if I had this one, x squared plus y squared equals 25, can I make that y equals?
Yeah.
Yes.
Alright, so let's make it y equals. What would I do?
Square root.
Move the x over.
Minus the x squared, so we get y squared equals 25 minus x squared, and then
Square root it.
take the square root. So what happens when I take the square root?
Plus or minus.
Plus or minus the square root of? So is that an explicit equation now?
Yeah.
Yes, but if I asked you to get its derivative, would you know how to get its derivative?
Yes.
Yes.
Yes, you would.
I mean, we could, but
So
why?
you know how to do something when it has plus or minus in it?
No.
Like 2 equations at the same time?
One's positive and a negative.
We had to practice that, right? I don't even want to get into it.
Yeah.
So that's why we're gonna get the derivative of it when it's written like this up here, rather than making it like this and then giving us some more headings down here. You understand?
So are we trying to go for an implicit?
We're trying to be able to get derivatives implicitly, so that way we can make our lives a lot simpler, right? But some of us like the hard life. Okay, are we good? Alright, this is very important, okay, especially for the upcoming lessons that we're gonna do next week. You have to know how to do implicit differentiation, and it might seem a little weird right now at the beginning, but hopefully it's not too bad, okay? So just try to follow along, and if you're a little bit lost at the beginning, I'll try to simplify it, and it'll make a little bit more sense as we go through it, okay? So don't just give up and get lost on it. Just stick with me, okay? Everything we're gonna be doing today will be finding derivatives with respect to a particular variable. Today it's with respect to x. In the future, when we start talking about real world problems, okay, and real world situations called related rates problem, we're gonna be talking about finding derivatives with respect to time, okay? Cool?
No.
So no big deal, all we did was change the x to a t, calm down.
Oh, actually.
Cool?
I guess.
Yes?
Yeah.
Alright, so anyways, let's look at these guys here, right? And we're gonna try to understand differentiating with respect to any variable, but for our examples, we're gonna do it with respect to what? To x. So you're gonna notice a deep what on the bottom?
Yes.
A
Yeah.
dx, okay? That's what we're gonna have all day today, and all day tomorrow. So when you see this right here, what is that telling you to do? It's an action.
Find the derivative.
Find the derivative with respect to x of what?
X.
Whatever's here, which in this case is x, right? Let's write that down. This means find the derivative, right? Okay, so just know that's what it means. With respect to x, but I'm not gonna write that. Are we good? So let's give it a try here. What would be the derivative of x with respect to x? Have we done that derivative before?
1.
Yeah? 1? Okay, cool. So could we think of this, sometimes they write this notation and sometimes they write this on the, they put d and then they put the x up there over dx.
Why?
Okay?
Because I equals 1.
They just don't like having it on the side. And what would that technically equal if we thought of it as just a fraction? It's not really that, but let's think of it like that.
1.
1? Isn't that what we said the derivative of x was?
Yeah.
What do you notice between these two letters here? This one and this one?
They're the same.
They match, right? So we're getting the derivative of something whose independent variable correlates to what we wanted its derivative of. Does that make sense?
Yeah.
Sort of, kind of? Look at the next one. Check the letters here, do they match?
No.
No. Right? What do you think the derivative of y with respect to x would be?
Nothing.
Y
What
over
do you-
over
Y over
x.
x.
Huh?
It's y over x.
dy, should I put it like this?
Yeah.
Over dx?
Yeah.
Okay. Really what you're doing here, when the variables do not match, and even when they do match, okay, you're getting the derivative of the variable with respect to that variable. So I'd be getting the derivative of y with respect to y, what would the derivative be?
1.
1, right? So there's really an imaginary 1 right here. And it's being multiplied by the derivative of that variable, which we don't know because it's with respect to a different variable. So what we're trying to do here is we're assuming, right, that y is some equation in terms of x. But we don't know for sure. So that's why we're finding its derivative implicit. Very good, good. You understand? It's like if somewhere in the background somebody would have told you, well, y is equal to 2x. But instead of putting a 2x, they put a
2y.
y, right? So we're going to assume that y, that letter, represents some equation that is in terms of what? X, but we don't know for sure. We're just assuming that it is.
Yes.
Yes? So if I were to get its derivative, it would be dy dx. Does that make sense? Sort of?
Yeah.
Yes? Maybe? Keep going, okay? Stay with me.
We got it, we got it.
You got it? Alright, let's look at this one. Okay? Differentiate the following with respect to x. So, we want the derivative of x to the third with respect to x. So what do you notice about the variables? They match, right? Okay, so let's do it. We're going to add parentheses here. We usually don't have them there, but I want to add them so that you can see that when you were doing the power rule, you were really doing the chain rule, you just didn't know that you were. Okay? So we would start off with technically seeing 2 layers, so do the outside one. So what would we get?
3x.
3, I'm going to put parentheses, x squared. And then we would still have to multiply by the derivative of what?
X.
So it would be like d dx of x, which really becomes 3x squared times dx dx, which we know is what? 1. So therefore we just end up with 3x squared.
What did they go with that?
So in reality, all the derivatives we've been doing that, we just didn't show all those steps. Does that make sense? Because the variables were always what? Matching, right? We were always getting the derivative with respect to x, and our equations all were in terms of x. So there was no problems. Now there will be problems, because now they won't be in terms of x. So check this guy out. Okay? Add the parentheses there. Think of it like that. You don't have to do this later, we're just doing it now. Okay? So do the variables match here?
No.
No. Okay, so we're gonna pretend that y is some equation, we don't know what it is, we don't know what could be anything, but it is something in terms of x. So we can get its derivative, but we're gonna get it implicitly. Okay? First thing you do is get the derivative of it like normal, in terms of y.
So 3y.
So what would it be? 3 parentheses y squared. And then you're gonna multiply that by the derivative of that letter
dy.
with respect to y, right? I mean, with respect to x. So when I do that, I get 3y squared, like we said, times dy dx. And I can't go any further than that, because I can't get the derivative of this equation y, because I don't really know what it is. If that makes any sense. It's a little weird, isn't it?
Yeah.
Yeah.
Okay, but it really just makes our life easy. We try another one?
Yeah.
We're lost.
Just a bit, but go.
Eventually, we'll get to the point where whenever we have an x with respect to x, we don't have to do this notation here. We can just get its derivative like normal. But I'm showing you now so you know that it's here. Okay? If it were with respect to t, then I would have to put here dx dt, because the letters don't match. That make sense?
Yeah.
Try the next one, okay? This one has something with x's and y's. So we got to get the derivative of each one individually, because it's addition, right? So we want the derivative with respect to x of x, plus the derivative with respect to x of 3y. Okay? So what would the derivative of this guy end up being?
1.
1, right? Can I just put 1 for now? right? Because it would be dx dx.
Are you ever gonna do it like, d over dy, like is that, like d with respect to y?
Yeah, we could do problems with respect to y, but we're not going to right now. Okay? Cool? So what would this one become?
1 plus
D3 1.
D3.
D3
Remember,
1.
get the derivative of it as normal with respect to that same letter y.
Three.
So what would be the derivative of 3y pretending it was that y was an x?
3.
3.
3. So you put a 3, then you multiply that by the actual derivative of y, which we don't know, so we're just gonna put what?
dy over
y
dx.
dx. That makes sense, sort of? And that would be my answer, 1 plus 3 dy dx. Cool? Try 6, what would we have to do on that one?
Product.
Product rule, right? Okay, so x is the first, y squared is the second. You ready? Product rule says what? Derivative of the?
First.
The d dx of the first x. I'm just writing out the rule. Times the what?
Second.
Second, which is y squared. Plus
First.
first, which is x, times
Derivative is 6.
the derivative, which is d dx of